Okay, now we're ready for problem 24. So now we're going to do some solving of equations with log functions. Actually, I hope pretty soon you realize that it's really not that difficult. Actually, problem 23. Ready for 23. 23 says solve the following equation. Log base 2 9x plus 3 equals 5. I explained before, usually most of the time if you have a log equation, especially if you have a log term equals a number, the way we're going to go about solving this, I'm going to rewrite this as an exponential equation. And here's the method I prefer. Right? 2 to the 5th equals 9x plus 3. All right, so we start out with a log equation that I have no idea how to solve. And now 2 to the 5th is 4, 8, 16, 32. This is the kind of equation you probably learned to solve in, I don't know, 6th, 7th grade. All right, subtract 3 from both sides. Of course, sometimes these problems, they don't always give you nice answers. If I didn't make any mistakes, I have x equals 29 over 9, and that is in fact correct. I hope you agree with me that that wasn't very hard. So if you ever have a log term equals a number, the way to solve it, convert the log term or convert the log equation to an exponential equation, and then it's usually pretty easy to solve. Now, let me teach you another principle about logs. Let me just make up a problem that we face sometimes. Say log 5 of x plus 2 log 5 of 4 equals 10. And we're asked to solve this equation. What we're going to do whenever we have an equation with like multiple log terms, this is a log term plus this is a log term. Remember, terms are things you either add or subtract. So I've got 2 log terms, and over here I have this third term, it's just a number. But the way we're going to go about solving equations like this, as it turns out, I'm going to show you that whenever you add or subtract log terms, you can actually combine them into one log term. So from now on, whenever you have an equation with multiple log terms, oftentimes the first thing we're going to do is we're going to combine them into one log term. So let's talk about how to do that. Because as a matter of fact, problem 24 is simply a problem about combining log terms. As a matter of fact, let me just write the problem, and then we're going to talk about how to solve this, and we'll come back and actually do this problem after we give a little explanation. 6 times log 3 of u plus 9 times log 3 of v. And the instructions are, write this expression as a single logarithm. In other words, you have two log terms, combine them into one log term. So we're going to go back to this in a minute. Let's talk about the rules that we have to follow in order to combine log terms. There's actually two conditions that have to be met before you combine log terms that are either added or subtracted. So this example, we're adding two log terms, but we could also subtract log terms, and we can also combine those into one. So whether we're adding or subtracting log terms, we can always combine them. Now the first condition is almost always met, because I think every problem they give you, this will be true, but we need to go and say it. To combine log terms, first, all the log terms have to have the same base. For instance, this example, 6 times log base 3 of u, 9 times log base 3 of v. Notice here, two log terms have to have the same bases. And in my experience, I haven't yet seen a problem in this class where they give you log terms at different bases. It's almost always the same base, but we need to go and say it just to make sure. Now the second one, we actually have to do some work sometimes. No coefficient in front of the log terms. Coefficient means just a number. So in other words, right here, 6 times log 3 base u, this 6 is a coefficient. So this first log term has a coefficient, plus 9 times log base 3 of v. The second term also has a coefficient. So it turns out both of these log terms have coefficients. As of right now, in the current state, I cannot combine these log terms. So let me give you the actual rules for combining log terms, and then we'll see what to do with these conditions, especially for number 2. Oftentimes, number 2 is not true. Just as a little heads up, what we're going to learn in a few minutes, we're going to learn to change each of these log terms and get rid of the coefficients. So I'm going to get rid of the 6 and get rid of the 9. That'll come in just a minute. First, the rule. Say I have log base a, so a can be anything, 2, 3, 5, 10, whatever. Log base a of x plus log base a of y. Two log terms, same base, no coefficients. So I've met the two conditions. How do we combine these into one log term? Well, it's going to be log a, and then what you do is, whenever we're adding two log terms, you simply take the stuff inside and you multiply it. So log base a, x times y. Let's just do a couple examples. How about log base 3 of 2x plus log base 3 of y squared. Two log terms, same base, no coefficients. I combine them into one log, log base 3, 2x times y squared. All right, not that hard, right? What happens if you end up having to subtract log terms? So I have log base a of x minus log base a of y. Okay, the two conditions have to be met, same base, no coefficients, and in this case, you can combine them into one log, but what you do is you take the stuff inside the first log term, and then whatever you're subtracting goes in the bottom. So it's like when you're adding log terms, you multiply the stuff inside the logs. When you're subtracting log terms, you take the stuff inside the first log and you divide it by the stuff inside the log you're subtracting. So if I turn this into a subtraction problem, log base 3 of 2x minus log base 3 of y squared equals two logs, same base, no coefficients. Since I'm subtracting 2x over y squared. All right, once again, not too bad. So then what can happen, let me just make something up for fun. How about I have log 7x minus log 7y plus log base 7w minus log base 7 of z, just for fun. So we actually have 4 log terms. Sometimes I'm subtracting, sometimes I'm adding. And I want to try and combine these all into one log term. All 4 logs have the same base. There are no coefficients. So what do we do? Going to have one big log. In a sense, one way you can think of it is whatever log terms are like positive, either you're adding them or they're already positive, those are going to like sort of go in the top. So this x and this w, since it's plus log base 7w, and then whatever log terms you're subtracting, those go in the bottom. So I'm subtracting log base 7y, subtracting log base 7z. So there you go. All right, hopefully those are pretty straightforward. Now there's one more twist. Earlier I said the conditions to combine log terms, same base, no coefficients. All right, well, that's nice, that's a condition, but you know what? That's just not sort of like the real world. To be honest, you're almost always going to have the same base, but the idea of no coefficients, you're going to have coefficients. So what do we do? Well, actually we're going to apply something we've already talked about. Remember when we talked about how we said if you ever have, to make it not confusing. So I had log base 2 of 4 cubed. Remember I said one of the special rules of logs is whenever you have an exponent inside the log, you can actually move the exponent in front of the log. Okay, well how about I reverse it? How about I start with 3 times log base 2 of 4 and I say I don't want that 3 out front. I can move it inside the log and it becomes an exponent. And that's what I'm going to do to each of these log terms. I cannot combine these log terms with these numbers or coefficients in front of the logs. However, I can get rid of them, or at least move them or change the form. I can move the 2 up here, and move the 3 up here. So 2 log base 5 of x is the same as log base 5 of x squared. 3 log base 5 of y is the same thing as log base 5 of y squared. So initially, I had coefficients or numbers in front of both my log terms, which means I cannot at this point combine them. But by doing this, now I don't have coefficients in front of the log terms, and I actually can combine them. So then I would say this equals log base 5. Since I'm adding, it's just x squared times y cubed. All right, so with that as the basis, now we're ready to work out problem 24. I want to combine these 2 log terms. I have the same base, but I have coefficients. Let's move the coefficients inside the log. So this is log base 3 of u to the 6th plus log base 3 v to the 9th. So now I'm able to meet the 2 conditions. 2 logs, same base, no coefficients. I can now combine these into 1 log term. And because we're adding these, you simply multiply the stuff. So it says when you combine it into 1 term, you get log base 3 of u to the 6th times v to the 9th. That is all of problem 24. I'm sure you're thinking, well, you would love to have one of those on the test. Let's do one more, since this next one I think is going to also be very easy. We've talked about this before. 25 says use the change of base formula and a calculator to evaluate the logarithm. We've talked about change of base. Remember, we spent time talking about how really there's 2 special logs, log base 10 or common log and log base e or natural log. And we talked about most of our calculators only do common log and natural log. So therefore, I cannot grab my calculator and I cannot determine this value. But change of base says, hey, you don't like log base 5? Fine. You can change it and choose whichever log you want. I'm going to choose log base 10, common log. Remember, change of base says I create a fraction of logs with the base of my choice. Then the 35 goes in the top. The original base goes in the bottom. So log base 5 of 35 equals common log of 35 divided by common log of 5. And actually now I can grab my calculator and I can do this calculation. And the answer says round to the nearest thousandth. Wow. So I have 2, the thousandths means 3 decimal places. 2.20, then it's 2.2090. So 2.209. And that is the correct answer. That would be a great test problem, huh? A change of base? Very simple. All right, so let me stop now, and we'll pick up the next video with problem 26.